All right, so we're going to do, what's that? Right, right when I'm getting ready, I had all that time. All that time I was passing papers out, everything else, and now I'm about to teach. And we got to go to the bathroom. All right, here we go. So what we're going to do first, we're going to talk about a line. It'd be nice if you'd pay attention. There's actually people in here that want to know how to do this stuff. Not everybody views this as a joke. All right, so we've talked about this, haven't we? This x and y axis and all that stuff. All right, so here's your x-axis, here's your y-axis. There is a z-axis, but we don't ever talk about it in this class. It is in the 3D, yeah. But that's for other math classes. It's not for our math class. All right, but there is a z-axis, three-dimensional, but we're not going to do that today. From Minecraft, okay? Yep. Oops. All right, so here we go. So if we had a line, and the line is, if it's a line, it keeps on going forever. Okay, we need to be able to describe this line to somebody, okay? So let's everybody listen now. So we need to be able to describe this line to somebody. The stuff we're doing right here, it doesn't seem very practical, but there's a ton of practicality to this kind of thing. And it's in the book. But I've decided, I don't know if it's a good thing or bad thing, but I don't know. For you, it's probably a good thing. But I've decided to skip the actual practical purposes of this, which is kind of stupid because the whole idea we're doing this is so you can use it in a real situation. But I don't care, as long as he's quiet. All right, so we need to be able to describe this line to somebody. All right, so there's one way you could describe it. What kind of line is this? We mentioned this when we were going over the homework. It's a positive slope, right? The slope of this line is a positive slope. So from going from left to right, it goes up, so we know it's a positive slope. So we're at least able to describe that. But that could mean like a multitude of lines, couldn't it? I mean, there's a ton of lines. There's actually an infinite number of lines that have a positive slope. All right, so just saying that it's a positive slope doesn't really help us. But there's a couple things that are really important. We're going to talk a little bit more about this tomorrow. But one of the things that's really important is what points it actually goes through. All right. So if I knew that this line went through this point, and I knew that a line went through this point, if I actually knew what that point was here, and if I actually knew what that point was right there, that's one unique point, isn't it? All right. It wouldn't be a multitude. There wouldn't be an infinite number of points. There's only one line that goes through those 2 points. You can't have any more. You just have one. Okay? So that's one thing that we're going to talk about. So we are going to talk about the slope. We're not just going to talk about that it's a positive slope. We're going to talk about the actual slope that it has. All right? But I could also have an infinite number of lines. Let me just copy and paste this. Look, I copied and pasted it. It has the same slope, but is it always going to be the same line just because it has the same slope? No, it's not just positive. It actually has the same exact number slope as what that one has. I mean, I could keep doing this all day long. I mean, I could do this the rest of my lifetime if I wanted to. Don't think I want to spend my life doing this, but you could just keep on putting line after line after line with the same slope, and you can have all these different lines, all right? So what we are really concerned about, we want one unique line, and so see, that's going to be, I'll call it xy, but instead of just xy, we'll call it x1, y1. We've done that before, didn't we? With the distance formula, right? And then what am I going to, if I call this x1, y1, what do you think I'm going to call this down here? Yeah, let's call it x, what, 2, y2. But sometimes they'll do this. Instead of using, oops, I put a 1 there. Instead of using the 1s and the 2s, sometimes they'll just do this. Instead of calling it x1, y1, they might call one of, what point? There we go. They might just call it xy. But I can't come down here and just call this xy, can I? because it would be the same point as this. So I got to call it something different. So a lot of times they'll just say this is x1, y1, and this is just xy instead of using the 2, all right? I'm going somewhere with this, all right? We're going to see something here in a second with this, all right? So one point, you can just call it x1, xy. The other point on that line, I could call x1, y1. Now, both of these points actually lie on that line. I'm not just taking 2 random points, okay? If I want to describe that particular line right there, I could find 2 points on the line, and that's basically one unique line. So with all that said, let's do this. Let me go back to white. What I'm going to do is we're going to write an equation of a line. This is the first one. We're going to look at 3, I think, different equations of a line. This is the first one that we're going to learn, and it's called the point-slope form. Point-slope form. And basically, it's just taken from the definition of the slope and just rearranged. That's all it is. So let me show you how we get to this. I could just write it down and say, okay, memorize it, but I'm going to show you where it comes from. It's very simple. We already talked about this earlier, how to find the slope between 2 points. It's the change in y over the change in x. Remember that? You subtract the y's, subtract the x's. Now, what we're going to do is we're going to use the point xy, and what was the other one that I wrote? X what? X1, Y1, okay? Everybody with me on that? All right, so we subtract the what and put it on top? The y's and put it on top. So I'm going to go y minus y1, okay? And then what do we put on the bottom? The x's, subtract the x's. So what? I got to subtract them in the same order. So if I went y minus y1, I have to go what? Yeah, that's a comma right there. I almost thought that was a 1. That's a comma. So x minus x1, okay? So that's one way that we could write the slope. Would you agree? Yeah. So what we're going to do now, to find the point-slope form, what they're going to do is they're going to get the y minus y1 by itself. Very simple. Just one little math step, and we've basically got our point-slope form. So how do I get that by itself? Let me ask you this. What do I want to get rid of? If I want that by itself, the x minus x1, right, the x's. So how can I get rid of that x minus x1? Like, do I add an x1 since that's being subtracted? Nah, this whole thing is being divided, correct? This whole x minus x1 is being divided. How do I get rid of something that's being divided? I multiply it. So I multiply this by what? X minus, x1, okay? So what will happen with that? They'll cancel out. What do I do over here? I multiply that by x minus x1. All right, so that cancels, that cancels. Remember how I said we're going to write this? We're going to write this with the y minus y1 being first. All right, so here's the point-slope form. We're basically there. Just going to rearrange some things a little bit. That's all we're going to do. So I got y minus y1 equals. Now, you could just write x minus x1 parentheses, then an m, but we usually write the m first. Okay, so I'm going to write the m first, and then I'm going to put the x minus x1. That right there is our point-slope form. So it's really just the slope just rearranged. That's all it is. All right? So it looks like a fancy equation and stuff, but we just took it from our slope. It's not really an equation. Our slope definition, our definition of slope. All right? And we just rearranged it. We came up with this. So what does it mean? That means that m is our slope, right? We already knew that. And the x1 and the y1 is one of the points on our line. And so is the x and the y. That's another point that lie on our line. They're not just random points just floating anywhere. They're 2 points that lie on this specific line. Okay? So let's do an example. I'll show you how to use this thing. It's really not difficult at all. It's very simple. That's why they start off with this one. All right, so let's do example 1. And the question says, write the equation of a line. So I'll write that out. Write the equation of a line. Now, one thing that they do here that I don't know if I'm really a big fan of, but they don't tell you like what form to put the equation of a line in. Okay, they've only showed you the one form right here, but I'm going to show you something here in a second. So write the equation of a line with a slope of negative 2/3, so that's the slope, and it passes through. So they only give you 1 point. They don't give you the 2 points like we talked about before. They just give you the 1 point. It passes through negative 4, 5. But they do tell you a couple things. They tell you what the slope is, and they tell you one of the points on that line. And what we have to do is figure out what the equation of that line is, so we know exactly what line is it. Okay? So they give you the slope, they give you 1 point on the line, and we basically have to find the equation of the line. All right? So here we go. What was our little formula? No. Y. No. Yeah, we're not doing y equals. We haven't even mentioned that. Y minus y1 equals what? M times x minus x1. Now, we are going to talk about y equals mx plus b when we finish this example, okay? But we haven't discussed that just yet. Tomorrow, we're going to talk a lot about it. All right. So let's take a look. Here we go. What do they tell you? Like, what's in this little formula? This little, yeah, it's a formula. The slope is, right? So what can I do? I could replace that m with a what? Negative 2 over 3. Okay, now what else could I replace in here?
The y and x.
Okay, but we're not going to replace the y and the x. We're going to replace the x1 and the y1, okay? So the x1 and the y1 actually represent the point that they give us. Everybody hear me on that? All right, so the point that they give us, we're going to put that in to the x1 and the y1. We're just going to keep the x and the y. We're just going to leave it, x and y. We're not going to mess with it. All right, but we will replace the x1 and the y1. All right, so let's do that. So I said that y is just going to stay y, correct? So I just make it y minus what? Minus 5, good. Where'd you get 5 from? Because that's the y of this point. Everybody see it? Equals m. Well, they tell you the m. What is it? It's negative 2 over 3. Then put a parentheses. Remember, the x and the y just stay x and y. We don't put another number in for it, okay? Just stays x and y. All right, so that stays x minus what? Minus negative 4. Good. All right, we're gonna add those up, right? Eventually. So minus negative is just same as plus. So I'll just do that. Now what we're gonna do is, they didn't tell you this, which I think they probably should have. I don't know. Maybe if I would have read a little bit closer, maybe they say it in there somewhere. But in the example, they don't say it. But what we're going to do is we're going to get y by itself. Okay, once we chuck everything in there, we're going to get y equals blah, 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 whatever's left. Everybody with me on that? Okay, so that's what we're going to try to do. All right. So what am I going to do if I want to simplify this thing and get y out there by itself? Yeah, you could add the 5, but I'm going to do something first before I do that. It's going to make it a lot easier. Look at that negative 2/3. You got a parentheses, so give me a good math word. Distribute. That's right. We're going to distribute that through here. So let's do that first. At the very end, we'll add the 5, okay? Everybody with me? So y minus 5 equals, that first part's easy. It's just what?
Negative 2 over 3x.
Yep, negative 2/3 x. All right, this next part, it's negative 2/3 plus, right, which is going to be what? Minus, agreed? Because it's a negative times a positive. All right. So how do we multiply that? We'll just multiply straight across the top. So what do we get? Minus what? 8 over what? This is 4 over 1, isn't it? So it's 3 times 1 is 3. All right. I know everybody freaks out when they see fractions, but that was super easy fraction stuff. Okay, when you multiply fractions, that's really easy. And then you add the 5, that's right. Now, when you add fractions, though, that's a little bit more difficult, but it shouldn't be too bad. Watch what I'm going to do. Everybody look, this is the key to this problem. If anybody doesn't know how to do this problem, it's probably because of this next step. And this is like an elementary school situation here, all right? I don't know when you learn fractions. When did you learn how to add fractions? Fourth, fifth grade? I doubt second grade. Fourth, fifth grade, maybe?
When they made us do it with the cubes.
Yeah. Okay. So anyway, whatever grade it was, I'm going to add it to here. So what's the most important thing to do when I add fractions together? Find the common what? Denominator. So what would the denominator, I'm not just going to put plus 5 here. I'm going to do a little bit in my head. So instead of writing it as a 5 over 1, it needs a common denominator of what? 3. So what's my numerator going to be? It's going to be 15, right? 5 times 3 is 15. 15 over 3 is the same thing as 5. Would you agree?
Yeah.
Sure. Okay, so 15 over 3 is 5. Megan, you need to put that away or I'm going to take it. This adds up. Y equals, and then what do we get? Negative 2/3 x. What's this? Negative 8/3 plus 15/3. So we can actually add these together. Negative 8 plus 15. What's 15 minus 8? Can you do that in your head? 7. So it's positive, right? Positive 7 or 7 over what? 3. So that right there is how they want you to write the answer. So they want the y by itself. Okay? Now, Nico said something a little earlier. It's something you've probably heard before. I don't know if we've talked about it in here. Have we done y equals mx plus b in here? We have done it in here?
We did it like last week.
Did we? Okay. I just can't remember. When we talked about b being the y-intercept and all that stuff? Okay, sorry. I teach a lot of different things to a lot of different people, and I forget what I taught and when I taught it. But yeah, we want to write it as y equals mx plus b, which is another form, which I'm going to talk about a little bit more tomorrow. But what do we call that form? Do you remember?
Standard.
No, it's not the standard. It's the slope-intercept. Good. It's called the slope-intercept form. We'll just put form down here. Okay? So this is an equation of a line right here, y equals mx plus b. And this is an equation of a line, y minus y1 equals m times x minus x1. All right? Except this one doesn't have a y-intercept in it, right? I can't just look at this and see what the y-intercept is. So what do I have to do? I got to solve for y, and then I can look at it, and now I can look at this and see what the y-intercept is. And I can find the slope. What's the use of this? Well, the use of this one is I can look at this, and I can tell you what the point is, or one of the points on the line, right? So I could see it's 5. I'm sorry, this would be it. So it would be negative 4, positive 5 by looking at that, all right? Let's just make up some random one. What if I said y plus 3 equals, I don't know, I'm just going to make some crazy slope, 5/7, and then x minus 2. What is the point? What is a point that lies on this line right here? Without even graphing it, without even plotting it, what is it? Well, I need a point, so I need an x and a y. So what's the x? Is it negative 2?
5/7.
No, that's the slope. I want a point on this line right here. The slope is 5/7. But
It's negative 2/3.
is it negative 2?
Positive 2/3.
Is it?
It's something 2/3.
Because look at this. It's minus x and a minus y. Do you see that?
Yeah.
So this is just my x1. So what's the x1? It's just a positive 2 because it's x minus whatever the x part is. Do you see that? There's the minus right there. There's the x right there. So what's the x1? It's just a plain old 2, positive 2. No. Okay. Man, I really thought you had a math question. Look at this right here. What? Let's not circle that. What's the y part of this point right here?
3.
Yeah, it looks like it.
Negative.
But remember, this is y minus. What are you subtracting from the y here? Subtracting a negative 3. Isn't this the same as y minus negative 3? Okay, so what's the y or the y1? What's the y1? It's negative 3. So I should just be able to look at an equation written in the point slope form and be able to tell what the slope is and be able to tell one point on that line. Is that enough to graph that unique line? One point and the slope? Absolutely it is. Yeah, that's plenty. So watch. Right? So if I told you a point, what was that one? 2, negative 3? All right. I just made that up off the top of my head. So 2, negative 3. So 1, 2, 1, 2, 3. Boom, a point right here. And then, so I know the point, right, just by looking at it. And then I know the slope, 5/7, right? So 1, 2, 3, 4, 5, and then 7 right there, okay? And there we go. So there's the slope, right? Rise and run. And now I can connect those two together. And that's one unique point, isn't it? There's no other point that has a slope of 5, or there's no other line, I'm sorry, that has a slope of 5/7 and goes through the point to -3. That's it right there. That's our line. Okay? So that's why that's important. Okay? That's why a point slope. But looking at it, can I just look at it and tell what the y-intercept is? No, can't do it. All right? But if I knew, if I know the slope and I know a point, I could put it in the point slope form, work it out, solve for y, and guess what? Now I have what? The y-intercept. Okay? All right. That's a lot of stuff, I know, but there we go. Let's see. I got one more example. We'll be done. We did example 1, so let's do example 2. Let's change colors. I'm tired of looking at that black and white. Example 2. It says write the equation of a line. Write it out again. Write the equation. Oops, it's supposed to be a Q. It's a weird looking Q. Equation of a line. Now this time, they don't tell you the slope. This time, they just give you 2 points. Okay? So how in the world are we going to use that thing if they don't even give us the slope? Well, you already know the what of the line. If they give you 2 points, you can find what? The slope. Exactly right. So there's just one little extra thing you got to do. You just got to find whatever the slope is instead of them telling you what it is. Okay? So here's the points. So if you didn't get that, that's fine. I'll go over it right now. And 8, -6. There's other ways you could do this, but they're teaching you the point slope form, so we're going to use the point slope form. All right? So let's just keep it right there. So let's write down the point slope form just so we remember it. Remember what it is? Y minus y1 equals m times x minus x1. Remember, the x1 and the y1 represent a point, okay? And the m represents a slope. First of all, do we know the slope? No, not right now, right? They didn't give it to us, but we could find it though, can't we? All right. Do we know a point? Yeah, we actually know more than 1 point. How many points do we know? We know both of them. The interesting thing is this. Everybody listen to this. The interesting thing is people say, well, how do I know what to put in for my x1 and my y1? It actually doesn't matter. The x1 and y1 represent any point that lies on the line. They gave me 2 points that lie on the line, so I could use either one of them. And you're going to get the same exact answer. That's kind of weird. You're putting in 2 completely different numbers, but you end up with the same exact equation. All right? I don't know. We don't have time, but you could put them both in and just see if that works. So let's do this quickly, and we'll be done. So first of all, we need to find the slope. So let's find the slope. So slope is changing y over changing x. So it's 4. Whoops. Stop doing that. 4 minus -6. And then the y's, or I'm sorry, that was the y's. Let's do the x's. -5 minus 8. And what do we get? 10 over what? -13. So that's my slope. All right, so that's what's going to go right here. We'll do that in a second. What am I going to put in for my x1 and my y1? Either one of these points. It doesn't make any difference. Which one would you rather put in? The -5, 4 or the 8, -6? All right, let's do the -5, 4. It doesn't make any difference. And if you don't believe me, after this class is over, right, before you do your homework, put them both in and you'll find out. You'll get the same exact equation at the very end. So y minus y1. So if we're using this point right here, what's our y1? 4. Equals m. We just found it. That's -10 over 13. And this is going to be x minus what? -5, which is, what's minus a negative? It's the same as +5, isn't it? Okay. Now, I'll tell you what, since time is running out, there's a little lightning bolt. You got to do the work. Okay, when you do the work, you're going to come out with this. Y equals negative 10 over 13x, and you're going to get a plus 2 over 13. This is just arithmetic, all right? Distribute, okay? Then add the 4. You're going to have to do a little bit of work with fractions, all right? So you need to do this. You need, see that lightning bolt? That's you. That's you doing the work, okay? So you do the work, and you should come out to this, all right? Your homework is numbers, it's section 2-3. It's 2-3A, section 2-3A. Even though, no, I think on Monday it does say 2-3. You're doing 13 to 24. 13 to 24. It's page 122 if you can't find section 2-3. There you go.